Okay, let's, don't know quite what it looks like, but here we go. Triangle, and then the goal is to find angle A. I'll just make that over there. And that means that the 11.6 would have to be across from it because that side A is across from angle A. And then I get some freedom to do the rest of it. So I'm just going to make 15.2. I'll make that. That's side B, which has to be across from angle B. And then C would be the last one, 7.4. Okay, now you should notice, well, the information that you started with in this problem is different than the information you started with in the last problem. If you had to classify this triangle information, how would you classify it? Yeah, this is side, side, side information triangle. And the last one, how would you classify this one? So yeah, there's two sides and an angle, side, side, angle, and you have to do it in that order. The angle is not in between. That's all that says, which is different than side, angle, side. That the order in which that says, it tells you the order in which the information is as you kind of rotate around the triangle. Okay, we can't do the same formula for this one. If we wanted to find this angle, we have to do something called the law of cosines. Now, the law of cosines is much different than this, and we won't do quite as much of an explanation of where it comes from as to show you where it is on this side. The law of cosines here, look at this right here, is this. There's more to it here, but what does it look like? What does that look like? Yeah, the Pythagorean theorem. So it looks like the Pythagorean theorem, but there's a little bit of extra minus 2ab cosine c. So think of it as like an adjustment for the fact that it's not a right triangle. Okay, we are going to use one of these two. They're both the same thing. This one has been solved. This is side c. So if you're trying to find side c, side little c, and this is obviously the angle c. It depends on what you want. In this case, what do we want? An angle. So we're going to use the version of this that's already got the angle isolated. Except this is where you have to adapt because the labeling system, the generic labeling system to this, angle C in this formula is kind of like the angle we're given in the problem here. So this is kind of a little bit of a juggling act with the lettering system. So here it goes. I'm just going to write it again. Cosine of angle C equals, and how's the rest of it? A squared plus B squared minus C squared all over 2AB. Okay, that would be set up appropriately if we were trying to find angle C, which we are not. Okay, you have to you have to sort of reset your brain. Let's relabel this. What we're trying to find is this. And in the formula, that would be the C. Okay, so you just kind of in order to put things in the right spot on this formula, let's call this, you have to kind of pretend that's not A, but we kind of know it's A. And we're going to label it C so that we put it in the right spots. Okay, we're going to just adapt. That means that this is side length C. So that is very important that's across from angle C. And then the B we can keep, this would be angle A, or angle A and side A. Okay, that wasn't the original labeling system. I'm kind of adapting it for use in this formula. You guys catch what I'm trying to do? Like, I could have done it this way too. I could have said that that's an A, and then that would be an A. You know, to try like the way this information is configured. So I could have gone that route too. It would have given me the same answer, but it's a little harder to switch through these. So I'm pretending for a moment that the angle A we're solving for is actually called angle C. Well, let's go ahead and put the numbers in and solve it. So cosine of C equals 7.4 squared plus 15.2 squared minus 11.6 squared, all divided by 2 times 7.4 times 15.2. Okay, again, we're gonna, and then we have to cosine inverse. So C is gonna be the cosine inverse of that. One calculation. Can you do it? It's like this. You ever had one of those little oranges, Stella? How many, can you peel off one of those little oranges so the peel comes off all at once? Or do you peel it off so that the peel is in like 17 different little pieces? Okay, we're trying to get you to peel off the orange in one peel. That's the goal. Okay, so you got your calculator? It'll help zone you in here. I want you to try to do this. I'm going to do it too. We'll see if we agree. 2.72 times, there's a 2 in it, 7.4 times 15.2. I'm going to do this all in one execution. Well, let that be there for a moment. Freeze it, and then here I go. I'm going to do it. You do it too. There's a lot of grouping that has to happen. That's what I'm trying to get out of this, is can you do this so that the order of operations in the calculator is accurate? Okay, I got something. Yeah, you get something? Frank, you get something?
Mine says error.
Error, okay, something happened. Probably because cosine, when you do this, whatever you plug in has to be less than, it has to be a decimal, like point something or other. And whatever you did, it doesn't like, which is probably has something to do with parentheses. So you have to group the top, group the bottom. Here you go, here's the reveal. You see if you got what I got. Would you want an answer in radians, or do you want an answer in degrees?
Well, it's telling me that I think I'm wrong about how many degree.
Yeah, you should be in degree. If you're in degrees, you should get about 47.7 degrees as the answer for this angle. Is that what you got?
Okay,
Add more parentheses. If all else fails, you got to group the top and the bottom.